All right, so this lesson will cover absolute value, solving absolute value equations. So this is part one. Part two will be inequalities. Okay, so the objectives today, the objectives are understand and solve absolute value equations and graph absolute value functions and use the graph to determine and verbally describe the solutions. So key terms on this lesson are absolute value equation, and we will get to these two tomorrow, okay, on the next lesson. So by now, you know what the graphs of absolute value functions look like. We know it's a V-shaped graph. And then how can we use what we know about those graphs and linear equations to solve absolute value equations and inequalities? So I'll let you guys think about this. So let's go to the next page for this, okay? And this is page 43. Now, remember that we are using the problem-solving model. So notice, organize, analyze, interpret, and then report, okay? So for this part, we are given a word problem, and we're going to try to make sense out of it by reading the information that we're given here. So this is creating an absolute value function from a situation. So this is a real-world situation. The official rules of baseball state that all baseballs used during professional games must be within a specified range of weights. The baseball manufacturer sets the target weight of the balls at 145.045 grams on its machines to ensure the baseballs they manufacture stay within the official rules. So number one, sketch a graph that models the relationship between a manufactured baseball's weight, X, and its distance from the target weight. And then explain target weight, Y. So this is distance from the target. Okay, explain how you constructed your sketch. So this is telling us that it's 145.045. So this is the manufacturer baseball weight in grams. So this is 145, so it should be somewhere about there. And notice I'm not being very picky on the graph because this is hard to work with when you don't have decimal values on the graph. Okay, so I'm just guesstimating. I know it's 145, so I'm just gonna go barely a little bit over 145. So this is 144, so 145. Then we know what the graph looks like. So I know this is going to be a V-shaped graph, so I'm going to say that maybe we have a point about there. And I'm going to sketch one side of the graph. Okay, that's one side. And then I'm going to put another point about right there if I go right one from that value. And again, we're not being picky here. We're just trying to get a visual of what it looks like. Okay. All right, so there is the graph of and as you can see, that's the absolute value function graph. So then part two says write an absolute value equation to represent the situation and the graph. Okay, so as you notice from transformation, remember I said don't forget the value of A, B, C, and D. So which value is this? Is that an A, a B, a C, or a D when the graph goes to the right of the origin? So then the absolute value equation is y equals the absolute value of x minus 145.045. Okay. So once we have the equation, let's ask ourselves, how is the function transformed from the parent function? And I just said this. The graph, since it's minus, and you can see it on here, on the graph, it got translated to the right 145.045 units. Okay, so let's go to the next page and let's see what we're being asked to do on the next page. Okay, on this page, we are told that the specified weight allows for a difference of 3.295 grams in the actual weight of a ball and the target weight. Okay, so that means you can be 3.95 grams over or under. Since the weight must be within a distance of 3.295 grams from the target weight, that means y equals 3.295. So graph the equation y equals 3.295 on the coordinate plane in question one. So I'm going to go back to the graph. So then this is approximately, we're saying 3.2, so we know this is 3. So let's say about right there. Then I'm going to sketch a graph. which is a line. Okay, I'm using a straight edge to help me get a straight line because I want to get a straight line here. And there we have the graph of that line. Okay, so this is y equals, let's see, 3.295. Okay, and this one here, maybe I should have done it in different colors, but I hope you understand. This is y equals the absolute value of x minus 145.045. And maybe I should also name it differently, but I hope you understand, 045. Okay, so those are the two graphs. So then when we're solving the equation, we're interested on the x value at this intersection and this intersection. As you can see, there are two intersections. Okay, so then to that end, let's go back to the other page, which is page 44. So graph, we just graphed that part. Okay, part B says, so part A was graphing, part B says, what two equations can you write without absolute values to show the least acceptable weight and the greatest acceptable weight of a baseball? Explain your reasoning. So there are two equations. One is we remove the absolute value. Again, don't forget this comes from the idea that absolute value is distance, right? So then one equation is, let's see, x minus 145.045 equals, what is this equation again?
3.
Okay, so that's what we write down. So then we say 3.295, that's one. Okay, the other, let me review. Don't forget, what is the opposite of 3.295? Negative, just change the sign. Very good. So then the other is, so or x minus 145.045 is equal to negative 3.295. This part you all know how to do. Okay, and explain your reasoning. So explain your reasoning here again, because we have, it's a distance from 0, so that's why we've got to have two values, one positive and one negative, again because of the absolute value. So then part C says, use a graph to write the solutions to the equations you wrote in part B and explain your reasoning. So to this end, I'm going to go to Desmos. I'm going to use the Desmos app. Okay, so then to solve this equation, what you would do is you would add 145.045, meaning you're not using the calculator or the graph, you're solving actually. Okay, so plus 145.045, and then that gives you that the approximate value for x is 148.34. That's this equation. Okay, so one intersection happens here. The other, same thing. I'm going to add 145.045 to both sides of the equal sign. And then this will give me x equals, for this one is 141.75. So there we have the x coordinates of the two intersections. So use the graph to write the solutions to the equations you wrote in part B. So explain your reasoning. Okay, so again, like you saw on the graph, on the TV screen, those of you that are here in the classroom, you can see where the line, the horizontal line intersects the V-shaped graph, okay, and it's at these values. So that's all you're doing basically. So explain your reasoning. I would just say, when I graph, so that will be in words. You okay with this so far? Okay, let's go to the next page. On the next page, this is activity 3.2. Okay, so this just explains, it says the two equations you wrote can be represented by the absolute value equation of W minus 145.045 equals 3.295. To solve any absolute value equation, recall the definition of absolute value. So then, a work example, consider the absolute value equation. The absolute value of A is 6, right? So there are 2 points that are 6 units away from 0 on the number line. So one to the right of 0 and one to the left of 0. So one is positive A is equal to 6, but negative A, the opposite of A, is equal to 6, which means that A is equal to 6 or A is equal to negative 6. So that's what this is saying. So the point is, Now, consider the case where a equals x minus 1. So you have the absolute value of x minus 1 is equal to 6. So in this case, we know that the absolute value of a is 6 can be written as two separate equations. You can write any absolute value equation, a is equal to 6, or the opposite of a is equal to 6. So then the same idea applies. You have x minus 1 is equal to 6, and the opposite of x minus 1 is equal to 6. Okay, so this is when you have two terms inside of the parentheses. So that's what's going to be different on this problem. So let's go to number 1. How do you know the expressions a and the opposite of a represent the opposite distances? So how would you think, what happens here? So let's do it different way. So for her, she said, okay, I have x minus 1 equals 6, which means I'm going to add 1. So then x equals 7. And for this one, she said, okay, x minus 1 equals negative 6. So I'm going to add 1 so I can solve for x. So then I find that x equals negative 5. So these are Lenz's solutions. Okay, let's see what Jackson did. Jackson, so for this one, you would add 1. So then we have x equals 7. And for this one, you would subtract 1. So then you have negative x equals 5. But then we don't want negative x, we want positive x. There's a negative 1 implied, so we divide by negative 1. So then solution for him is also negative 5. Did they get the same solutions?
No.
Did they get the same solutions?
No.
They didn't? 7, negative 5, 7, negative 5. Okay, so what's the point here? All right, so let's go to the next page. And here, so solve each absolute value equations and show your work. So I'm going to do A, B, and C. Okay, so I'm going to do those three. I'm gonna have you try D. So for this one, don't forget, we have two solutions. Okay, so then one is x plus 7 equals 3, and the other is x plus 7 equals negative 3. So then for this one, you would subtract the 7. And then we say 3 minus 7, that's a negative 4. Okay, so that's one solution. The other, do the same thing, subtract 7. So then we have x equals negative 3 minus 7, that's a negative 10. So solutions are x equals negative 4 or x equals negative 10. So there are the solutions to this equation. Let's look at problem B. Okay, and I want you to see, I want to see if you catch this. Is it possible that when you take the absolute value of a number, you get a negative solution? If it's the absolute value. Is that possible? We're taking the absolute value of this, can that give us a negative number? You can't, right? If it's absolute value, it has to be positive. So then in this case, for this one, we say no solution. And for those of you that are in the classroom, I'm going to show it to you. So then for this one, we say x minus 9 equals negative 12. That's one. Or the other is x minus 9 equals positive 12. And then we solve. So I'm going to add 9. So then negative 12 plus 9, that is equal to negative 3. And this one I'm going to add 9 also. But now I'm adding 12 and 9. When I add 12 and 9, I end up getting 21. So solutions are x equals negative 3 or x equals 21. So that means these two graphs, this line and this V-shaped graph, are going to intersect at the values of x is negative 3 and x is positive 21. So I'm going to have you try part D. So go ahead and try D. So then the solution to this one is negative 3 halves or negative 1.5. Okay. So let's go to page 47. And I am not going to go over A and B, but I want you to see these. These are a little bit different. Okay, so I'm going to go over each one of them. Notice there is something with the absolute value here. For example, if I had x plus 16 equals 32. My goal is to get the x by itself. Well, in this case, my goal is to get the absolute value by itself. Okay, so then to that end, I would subtract 16 here and also on this side. So it's the same idea. I'm going to subtract 16 from this side and 16 from 32. And when I subtract 16 from 32, that gives me the absolute value by itself. And that equals 16 minus, 32 minus 16, that's 16. So notice, I have the absolute value by itself. The next thing I do is, okay, which values, okay, are at a distance of 16 from x? And there's two of them. So which are they? When I remove the absolute value, I have to say x equals what? And x, what is the other one? So x equals, one is a positive, the other one is the negative. So then positive 16, the other is negative 16. So again, the question is, let's go to example B. Same thing, I have the absolute value here. I need to isolate it. There's a 6 with it. I'm going to subtract that 6 from both sides of the equal sign. And then 23 minus 6, that gives us a 17. Absolute value of x minus 8. Once the absolute value is isolated, then I can set up the two equations. Okay, so then one is 17 equals x minus 8. That's one. And the other is negative 17 equals x minus 8.